Now that you've analyzed the data for 22 April 2011 and compared it to the historical tornadoes, now let's go ahead and download your own data from the same location where the 22 April data sets were gathered. You will compare another day's storms to 22 April, temporally and spatially. So this particular part of the lesson asks you to go out to the NOAA Storm Prediction Center, right here at this URL at noaa.gov. Scroll down to the place where you can enter a date. Select any date you wish. One interesting date would be the day that saw more tornadoes than any in the past 40 years, which was actually 27 April 2011, about a week later. This was the sad day in which many lives were lost in Mississippi, Alabama, and Georgia. If you use this date, you will obtain the following page and map. You can see the pattern here on this map on the web. Next, select CSV, not raw tornado CSV, but just plain old CSV, a comma-separated value table of the data, which you will bring to your GIS for further analysis. Save this CSV in your working folder. Open your CSV file in Excel. Observe some things, go back to ArcMap, and use the Add Data button to add the CSV file. You'll indicate what kind of data is incoming. And then what you will do then is map your 27 April, or whatever day you select, day, and compare it to the 22 April 2011 pattern that we were looking at earlier. Finally, in a paragraph, compare the day's pattern of wind and hail, temporally and spatially, to the wind and hail from the 22 April 2011 that you analyzed earlier. Synthesis. Give a 5-minute presentation to your classmates, as if they were the FEMA director, that includes your assessment of the 2 days of storms that you have analyzed. Use your maps and data to support your presentation and recommendations. Write a paragraph describing what you have learned about tornadoes, wind, and hail in this lesson. Write a paragraph describing what you have learned about the spatial pattern of a single day of severe storms and how GIS helped you to understand these patterns. I'd like to just add an additional note here. Inside ArcGIS Desktop, remember you've got these base maps that we were looking at earlier. Let's turn off the tornado touchdowns from 1950 to 2004 for the moment and go back to looking at this 1 day's worth of tornadoes. You know, we were looking at, for example, the tornadoes around the St. Louis airport. So let's go ahead and zoom over there. We have the capability of changing the base map, as you know. But since we're connected to ArcGIS Online, we've got all that wealth of data as well. So I'm going to go ahead and zoom into the airport. Okay, these were the tornadoes that were right around the airport that day. Now I'm going to change the base map. I'm going to select this Bing Maps aerial. Now I've got an aerial image showing the tornadoes on top of the aerial. Here's the airport. I'm going to zoom in there a bit further. And now I can see the tornadoes that were right around the airport that day, along with the runway and the terminal. So remember, you've got a wealth of data here at your fingertips. You're not limited to what I specified in the lesson. Here I'm looking at the tornado now in conjunction with these runways and the terminal, and there's another one out to the west. Remember, you've got a GIS at your fingertips. You can analyze and study spatial and temporal patterns of not just storms and tornadoes as we've looked at here, but a wealth of data. Anything that has a location you can analyze in a GIS.
Wasn't it interesting looking at 1 day's worth of severe storms? Did you notice how the pattern changed as the day went on? So we're linking the spatial perspective and the temporal or time perspective. When you think about it, there's a whole host of other data and phenomena that can be examined using a tool like ArcGIS Online, a geographic information system. Think about earthquakes, volcanoes, the location of businesses in your community, traffic patterns. A whole host of things can be examined because they take place across space and they also change over time. So I encourage you to use geographic information systems, including ArcGIS Online, to investigate phenomena in our world from a global to local scale that change over space and time. Thanks.